Good morning, ladies and gentlemen. Welcome to the video notes for Chapter 5, Section 3 in your geometry book, covering inequalities in one triangle. We are going to start off in this video discussing inequalities in general in terms of algebra rules, and then we will advance into the two new geometry rules for this section as well as their examples. So this first video is going to cover the properties of inequalities that you should already know from algebra, and then it will extend into the first new rule, the exterior angle inequality theorem. In our second video, we'll cover the second theorem in this section, the slam theorem. So here we go. We start off talking about the trichotomy property of real numbers, which says for any two real numbers a and b, exactly one of three relationships exist. Either a is greater than b, i.e. a is greater than b, a is equal to b, a equals b, or a is less than b, a is less than b. That can only be one of those three situations. It cannot be two of them at a time. Now that being said, on occasion we don't know which one it is, so we do have two other important symbols that come up. We have the greater than or equal to symbol, and we have the less than or equal to symbol. Okay? Those are only used when we do not know which of these three properties exists. But again, it can only be one of the three when it finally is solved, when it comes down to it. If we know both values, it can only have one of these three properties. Either a is greater than b, a is equal to b, or a is less than b. Next up, we have a couple of algebra properties that apply to inequalities just like they did to equations. Starting off with the transitive property of inequality, which says that if a is greater than b and b is greater than c, then that means that a has to be greater than c. The same thing would apply to less than. So if a is less than b and b is less than c, then a is less than c. This is the same property that we had with equality. It applies to inequalities exactly the same way that it does to equality, which means that when we combine those into a greater than equal to or a less than equal to, the transitive property would still apply. The addition property of equalities stated that we were allowed to add whatever we wanted to both sides of an equation. As it turns out, that property also exists in inequalities. So if a is greater than b, then we can add whatever we want to both sides of that inequality, meaning that a plus c is greater than b plus c. In addition, that would apply to less than as well. If a is less than b, then a plus c is less than b plus c. The subtraction property basically says the same thing, except instead of addition, it says we are allowed to subtract whatever we want from both sides of an inequality. So we'd write that out as well. Now, why, you would ask yourself, is he only listing addition and subtraction at this point? First of all, addition and subtraction would apply the exact same way they do to equality, which is why we're listing them here. But the big thing here is that with multiplication and division, our algebra rules do not hold for inequalities. What I mean by that is when we multiply or divide by a negative number, we have to reverse the inequality symbol. So those properties are different for inequality than they are for equality. That's why multiplication and division are not listed here. So these three properties are the same for inequalities that they are for equality, meaning that the rules we already had in place from Chapter 2 definitely still apply here for inequalities. All right, so moving into actual geometry, we start off with a rule called the exterior angle inequality theorem. Now that is a very different theorem from the one that we learned earlier in the book. In section 4-2, we learned the exterior angle in theorem for triangles, which with this same picture, it said the measure of angle 1, which is the exterior angle, is equal to the sum of the remote interior angles. So that was what we learned in chapter 4. Here, things are a little bit different. Because angle 1 is equal to the sum of angles 2 and 3, because it's equal to angle 2 plus angle 3, it makes sense that angle 1 would have to be larger than angle 2. That angle 1 would have to be larger than angle 3, because in order to get angle 1, you would have to add angles 2 and 3 together, which would indicate that both of those angles are smaller than angle 1. So the way this reads is an exterior angle of a triangle must have greater measure than either of the remote interior angles. So based on that picture above, if angle 1 is an exterior angle, as pictured, that means that the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. So that's what the rule says. Angle 1 is greater than angle 2. Angle 1 is greater than angle 3. So let's apply that. Here we have a picture with several triangles in it. We're going to do 2 of these. With a couple of exterior angles listed as well. We're supposed to use the exterior angle inequality theorem to list all angles which satisfy the given condition. Now we are going to stick only to angles that can be proven to have this condition based on that rule. There are some other rules we could apply that might get us a few more answers, but we're only looking for angles that satisfy these conditions based on this rule. That's the key. We're only using that rule. So, looking for angle measures that are less than angle 7. Well, angle 7 is exterior to triangle. We'll start with triangle LMK. Okay, it is exterior to this triangle right here, LMK. And in that situation, the remote interior angles are angles 4 and 5. Which our rule, the exterior angle inequality theorem, says it must be bigger than those 2 angles. So that would be enough information. If 7 is exterior to triangle LMK, that would guarantee that the measure of angle 7 is greater than the measure of angle 5, so that'd be one answer, and the measure of angle 7 is greater than the measure of angle 4, so that would be a second answer. Now that's not the only triangle that angle 7 is exterior to. Angle 7 is also exterior to triangle LJK. That would be this triangle here. And in that triangle, angle 1 is remote interior, and the combination of angles 2 and 4 is remote interior, which means that angle 7 is bigger than angle 1, and angle 7 is bigger than the sum of angles 2 and 4. So that's going to give us a couple more answers. Let me get that protractor out of the way. Okay. Since angle 7 is exterior to angle LJK, the measure of angle 7 must be greater than the measure of angle 1, so there's another answer. And the measure of angle 7 must be greater than the sum of angles 2 and 4. Since I already know it's bigger than angle 4, this would add, we also know that it's bigger than the measure of angle 2. So we have 4 answers in part A: angle 5, angle 4, angle 1, and angle 2. Okay, part B says angle measures greater than the measure of angle 6. Now, if we look at angle 6, there's only one triangle that we need to consider, and that is this triangle, the same one we just had highlighted, LJK. Because in that triangle, angle 6 and angle 1 are remote interior angles for angle 8. Angle 8 is exterior to that triangle. Okay, so that gives us one answer here. And actually, I just realized there's another one. So that's the first one I saw, and there is another one now that I look closer at the picture. Based on the exterior angle inequality theorem, if angle 8 is exterior to this triangle that I have highlighted, that means it is definitely bigger than angle 6. So our first answer would be based on that thought that angle 8 is exterior to triangle LJK, which tells us that the measure of angle 8 is greater than the measure of angle 6. Now, angle 8 is also greater than angle 1, but that's not what we're dealing with. We're looking for angles that are bigger than angle 6, so that's all we focus on. There is a second exterior angle that has angle 6 as a remote interior angle, and that is this triangle here. Angle 3 is exterior, guaranteeing that it is bigger than angles 4 and 6. So same reasoning, we would be able to say that since angle 3 is exterior to triangle LMK, that the measure of angle 3 is greater than the measure of angle 6. So there's only two angles in this picture that we can 100% guarantee are bigger than angle 6. I know that, well, at least with this rule, I know that the way it's drawn, angle 7 is bigger than angle 6, but that's not based on the exterior angle inequality theorem, so we ignore that. We're only looking for angles based on that rule. Now there is another one of these on the next slide, so please pause the video and try it on your own, and then resume the video to see how you did. Okay, so this one, the pictures looks a lot more complicated, but it's actually a lot simpler. There are less exterior angles to worry about, so there are less answers, to be 100% honest. So here we go. Angle 1 is exterior to triangle PQR. Okay, it is exterior to triangle PQR, this one. So since it's exterior, it is bigger than the sum of 3 and 4, because that would be one remote interior angle, and it's bigger than the sum of 5 and 6, because that would be another remote interior angle. So that means it is definitely bigger than all 4 of those angles. Okay, because it's exterior to that triangle, the measure of angle 1 is greater than the sum of angles 3 and 4, because that's one of the remote interior angles. So both of those would be answers. And it is bigger than the sum of angles 5 and 6. I'm actually wishing I'd space this out a little bit more so I could just circle my answers. So I'm just going to move it just a little bit. Okay, again, if it's bigger than the sum of these angles, it is bigger than either one of the angles that's contained within that sum. So the exterior angle inequality theorem would give us 4 answers for part A: angle 3, angle 4, angle 5, and angle 6. Again, angle 1 is probably bigger than angle 8, but that is not based on the rule that we are dealing with in the directions, which is the exterior angle inequality theorem. So we ignore any other rule that might give us potential answers here. Okay. Finally, on part B, we're looking for angle measures that are greater than angle 8. There is only one angle in this picture based on the exterior angle inequality theorem that we can guarantee is greater than angle 8, and that is angle 2. Angle 2 is exterior to triangle PQR. Which means that the measure of angle 2 is definitely greater than the measure of angle 8. Now, angle 1 is exterior to that triangle, but 8 is not a remote interior angles, so we cannot use that rule. The rest of the angles in this picture are not exterior to a triangle that contains angle 8, so none of them would follow this rule. Angle 2 would be the only answer for part B based on the exterior angle inequality theorem. That does it for the first video. Our next video will cover the other rule in this section. Thank you very much for your time and attention.